Now, the control systems of the body, there's two. There's the nervous system and there's the endocrine system, and they control the whole body. But when we're talking about the body, a really important concept that comes up is, something that both of these systems try and achieve. So the nervous system and the endocrine system, they both work to achieve something called homeostasis. So homeostasis means basically a stable internal environment. So, your body temperature, it's about 37 degrees and it doesn't change much. If it goes up to 45, you'll be dead. If it drops down to too low, 20 degrees, you'll probably be dead too. But there's all sorts of things that are maintained at homeostatic or, stable levels, and it's temperature. It's the amount of glucose in your blood. It's the amount of salt in your blood. It's the amount of water in your body. We need to have a really stable internal environment for the amazing array of things that happen in our body to take place appropriately. And when we're talking about homeostasis, something called the stimulus response model comes up. So what that basically is a way that the control systems of the body work. The body receives some form of a stimulus, and then a series of steps happen. So there's a receptor in the body that gets the message of that stimulus. That message is sent to a control center where a decision is made. The control center sends the action to an effector. An effector is often a muscle, or it could be a gland, and the effector does something. And it does something, and that is basically, it ends up being a response. So it's called a stimulus response model because when the body gets a stimulus, a response will often happen. And often, in fact, all the time, to achieve homeostasis, when a stimulus happens, the response negates the effect of that stimulus. And it's called negative feedback. So this is a negative feedback system. I'll give you an example. So if a stimulus is the body, you're too hot is the stimulus to the body, then the receptors, there might be receptors in the skin, temperature receptors, or there's in fact a temperature receptor in your brain, in your hypothalamus, and it might say, well, it's too hot. We need to do something here. So the message would then go to a control center. The control center, the brain would say, well, we need to do something here. We need to get cooler. It would send a message. It might send a message to our muscles, our effectors. So that's our muscles. And the response might be to take our jumper off. So of course we take our jumper off. We'll get colder when we take our jumper off, and that will negate, or that will offset the effect of the original stimulus being heat. So if we're hot, receptor, control center, effector, the response is take our jumper off, and that makes us less hot. Or we could be cold. The stimulus might be you're cold, a receptor might be the temperature receptors, the control center might be the brain. The brain sends a message to our muscles again, and this time we shiver. And as a result, we get warmer. A stimulus could be that you're thirsty. You don't have enough water in your body. A receptor would be the brain, the control center, or receptors would be, again, the hypothalamus, in fact, which decides how much water is in our body. The control center would be the brain, and it might just say, again, we'll pick up a glass of water and have a drink. So if we're thirsty, we don't have enough water, a negative feedback system would happen to make us not thirsty anymore. So these stimulus response models and this negative feedback system happens all the time to make sure that we maintain homeostasis, or our internal environment is always at the same level.